This is an overview of our vehicle trajectory analysis program. It's intended to process vehicle data in a graphical way. To explain, we have a graphical display screen. We can optionally put a satellite or aerial photo background on, and in this case we have a aerial photo of the Calder oval where some of our testing was done. The program allows you to open a data file. We can then select an appropriate file. We'll use a braking test number 30. We accept this and we get the file loaded. We can zoom into the region of interest, and there is a color-coded display where cyan is a stationary vehicle. Then as speed increases, the colors go from green through orange to eventually red. So we can see our braking test. We know from experience that the test started at the bottom of the screen. The car accelerated to some maximum speed, and then the braking test was performed at the end of the trajectory at the top of the screen. Now we have the data loaded, we can look at some parameters. So we can check the velocity. We get a strip chart displayed, and this shows us a profile of velocity on the vertical axis and time on the horizontal axis. We express time in terms of frames due to the ability of the program to accept data from a couple of different formats. So we have the ability to click on the active area of the chart and get a vertical line. We can then drag this line across, and the velocity under the line is shown in the status bar. So we can see the maximum speed, which would be about here, will be after 10 seconds from the start of the run, and a speed of 80 kilometers an hour was reached. We also have a couple of other calculations available. We can calculate the averages. So the elapsed time was 13.5 seconds for this maneuver. We had 134 frames. The frames are determined according to a frame rate the recording device uses, and our average velocity was 46.3 kilometers an hour, and we also display the minimum and maximum. We can close that. We can also calculate the distance taken for this braking maneuver. So we do a calculate there for the entire profile, and we find 173 meters and 13.4 seconds. We can also extract a segment, so we can specify velocity between two positions. So we can close this temporarily. We can set a start position, which might be there, and we set the start time, which will be frame 66. We then drag the line to some other position. We return the display or the form. We set the end time, and then we can save that path as a segment, which we can call test 1. Save that, and it will tell us our start and end times. We can now close. We can close the main velocity form. We can reset the display, and then we can go in and find the test, accept it, and we find we've saved that small segment according to velocity. We can then go into the velocity display, and we now have a segment of the previous profile. If we return to the original profile we had, that's back again. We can also display the pitch and roll angles for the vehicle in degrees. Again, we have the ability to drag a line and see the values on the status bar. We also have the ability to turn the lines on and off using the check boxes. We can close that. The main chart of interest is the acceleration profiles. So we can simplify this by turning off the GY and GZ. GX is the longitudinal acceleration, So what we have in this case is an acceleration at the beginning, which moves down to approximately constant velocity, and then we get the big braking spike, and then some variation as the vehicle is braking, and then when it comes to a halt we return to zero. Gy is the lateral acceleration, so we can look at this and we can see there is a little bit of lateral movement as the car's aligning along the path. And Gz is the vertical acceleration, and we can really see that there are some oscillations primarily during the braking maneuver. And we can turn them all on again. By default these all have the noise filtered out. And we can do a calculation of the averages. So we simply calculate and we get the minimum peak, the average and the maximum peak for each of the longitudinal, lateral and normal accelerations. And that's a brief overview of the vehicle trajectory analysis program.